Adult male red kangaroos are approximately normally distributed with a mean of 1.2 meters and a standard deviation of 10 meters. First thing I would do is I would write down, because they're giving you a lot of information in this one, so this was red. You can't even see this. Oh my God. Let's try it. The red kangaroos are normal, right? With the mean of 120 and a standard deviation of 0.1. Okay? And then the heights of the gray kangaroos are normal with 1.75 and 0.25, right? All right, then it says a certain gray kangaroo is 2.05 meters tall. So the gray one is x equals 2.05 meters tall. This kangaroo would have the same standardized height score as an adult red kangaroo whose height in meters is equal to which of the following. So you're trying to find the height of the red kangaroo that has the same z-score as this gray kangaroo. But you can't see any of this stuff. Okay, so how do you find, so you want the z-score, right, first. Hang on. You want the z-score, right, first. So, maybe you can see that. So how do I find the z-score of the gray kangaroo? So what's x? 2.05. Then minus what? The mean of the gray one, right? Because this is all gray. So 1.75 divided by 0.25. So you get that z-score, and what do you get? 1 point what? 2. Okay? So that's the z-score for the gray kangaroo. So label that, write that down, and put that's the z-score for the gray kangaroo. Right? Is everybody with me? Okay. So we need to find the height that's going to give us the same z-score as that for the red kangaroo, right? So we want the z-score for the red kangaroo to be 1.2. We don't know what x is. That's what we're trying to find, right? Yes. Oops. And we're going to minus what for this one? 1.20, because now we're on the red kangaroo. And we're going to divide that by 0.1. Okay? 2 ways you could do this. Somebody tell me one way you could do this. Work backwards. How? Yeah, plug in the answer choices for x. Do 1.08 minus 1.2 divided by 0.1 and see if it gives you 1.2. If it doesn't, do the next one. What's another way to do that? Do the algebra. Solve for x. So you would do 1.2 times 0.1 and then add 1.2. Okay? Questions? So the hardest part of this was trying to figure out what information they were giving you and what belonged to who. So in this case, even though you don't have to show work on multiple choice, this is the kind of problem where you should show a lot of work so that you stay organized in your head with what you're doing. Okay? Questions on that one? Any questions? Okay. All right, let's go to number 2. Is that the next one we did? Okay. All right, let me erase all this stuff. All right. So on number 2, it says, the height of mature maple trees are approximately normally distributed. As soon as I see those words approximately normally distributed, I write down in parentheses. Okay? Even if it's a multiple choice, just so I remember. And with a mean of 80 feet and a standard deviation of 12.5 feet. What proportion of mature maple trees are between 65 and 90? So they want the probability between, what did it say, 68 Whoops. That's a 5. 65 and 90. So this is what? Straight calculator, right? Where do you go? How do you get there? Second vars, normal CDF, and then what's your lower bound going to be? 65. Upper bound's going to be 90. Mean, standard deviation, you already wrote it down, so you don't have to go back and read the problem. Okay? And then which one's the answer? C. What was the answer for number 1? I don't think I told you. D. Did you ever get D for number 1? I don't think I told you all that. Okay? That one's a pretty straightforward, easy problem, right? That one should take you less than 2 minutes, hopefully. Okay? So now we're going to what number? 9. Nine was a tough problem. Now, when you go to take the AP exam, you are not going to be able to answer every single question on that multiple choice. Okay? Nobody can. All right? There's stuff you're going to forget, stuff that hasn't been presented to you in the way that they are asking the question. Okay? So that's why you need to pick and choose while you go through the questions. Don't answer 1, 2, 3, 4, 5, 6, 7. Because you're wasting your time. Because what if 1 through 10 are super hard, and you spend all your time on those, and then the ones at the end of the numbers 30 through 40 were super easy, and you didn't have time to get there. Okay, so skip around. Do the ones you know how to do first, and then go back and work on the other ones. Okay? All right, this one says the distribution of heights of a simple random sample of 400 young children. The first thing I would write down is n equals 400. Approximately normal, and produce the following summary of statistics. So they give you the mean and the median. What does that tell you right there? It's normal. Why? Because they're equal. Standard deviation is 2 inches. The first quartile is 45.7 inches. What does that tell you? What does first quartile mean? Think of a box plot. Q1, right? But what percent is Q1? 25%. Remember that? Each quartile is 25%. So this is Q1. What's the third quartile tell you? 75%. Okay? Well, 75% is, no, I take that back. That's not. We'll come back to that. I'm not sure. Hang on.
Yeah, because the second quartile is 50.
Yeah, but it's 75% below that, right?
Yeah.
Yes. Third quartile is 75% is below that. Yeah. All right. So, what did I tell you? I gave you a hint on this to do what? Now, how did I know to do that? Because I'm super smart, right? No. Because I read the answers. The answers are talking about what? They're talking about certain numbers of kids, right? And they're talking about their heights. And they're giving ranges at some point. Okay? So I thought about this and I thought, okay, well, let me look at this. It's 64 kids of the sample. 64 of how many? So somebody put that in the calculator and get the percent. 16%? So I wrote that down on the side. So 200 is what? 50. So I wrote that down on the side. Next one is 200. What's the next one? 336 out of 400. 84. And 380 out of 400 is what? 95. Ooh, 95 sounds like a familiar number, doesn't it? From what? From the empirical rule, right? So that gave me a clue, hey, maybe I need to draw this, okay? So I drew the curve. This is a tough problem, I thought. So you get 47, right? And the standard deviation is 2, so you know this is 49, 51, 53, right? and then 44, 45, 43, and 41. I know you can't see that, I'm sorry. Okay? So now look at the numbers they gave you here. Greater than 49, between 45 and 49, 47, 45, and 43 and 51. All those numbers are on the thing you just drew, right? So that's going to give you a clue there, okay? So sometimes if you draw the stuff out, you'll get a hint, okay? So the first one says 16% of the 16% of the children in the sample have heights that are greater than 49 inches. So 49 and up. So that's on a standard deviation line, right? And if it's on a standard deviation line, you can use the empirical rule, right? So how many percent is in from 49 down? How much is this one from here to here? 50. How much is from here to here? 34, right? Just this one. So 50 and 34 is what? 84. That's 100 minus 84. 16. Okay? So that means 16% are greater than 49. So that's true. Now, our question's asking us what? Which is false. So we got to keep going. Okay? Do you think you can do the rest yourself? Okay, try those four. See, look to see where those ranges are and look to see if those percents match what you just figured out. Okay? So just really quick, see if you can figure out which one is false. If you don't remember the percents, look them up on the front of your packet. It has the empirical rule. That's one thing you need to memorize for sure is the empirical rule and the breakdown of each area, what percents are in each area. Okay? All right, so what answer did we get? B. Okay, because if it said B said 50% should be between 45 and 49. 45 and 49 are here. So that's really what? 68%. So that's the one that's wrong, is B. Okay? So that's probably a question you would skip and do towards the end, right? Because that took a lot of work and most of you probably were clueless. I didn't know how to do it the first time I read it. Okay? So that's probably one you would skip and go back to. All right. Number 10. Number 10 says, this was another problem that took a lot of work. Let me find mine. Number 10 says, golf balls must meet a certain standard of distance traveled in order to be used in a professional tournament. When the ball is hit by a mechanical device under specific calibration, the ball may not travel further than 291.2 yards in the air. From past data, a certain manufacturer has determined that the distances traveled for the balls it produces are normally distributed. So I'm going to write down my N, and with a mean of 290 yards. They don't know it, then it says what's the standard deviation. So they're not giving you the standard deviation. Okay? But what are they giving you? The percent or the probability. These all mean the same thing. Okay? So they're giving you that, but they want the standard deviation. Okay, so how are we going to do that? What do we have in our bag of tricks that we know we can use with normal and with percent? Z-score. Okay, so when we know Z-score is x minus mu over standard deviation. Okay, well I don't have a Z-score. I'm looking for the standard deviation. Do I have an x? What's my x? 291.2, right? And you have a mu, which was 290. So we're missing two things, so how was the Z-score going to help us? And where? Inverse normal. So let's look at inverse normal. I don't have a calculator on here, so everybody go to second bars and go to inverse normal. What's it asking for?
Area.
And?
The mu sigma.
And the standard deviation, but we don't know the standard deviation, right? So we can't use that one. All right? I know. Darn it. Gonna have to think, okay? So, but I do have this percent, right? Can I get the Z-score for this percent somewhere else?
Yes.
Where? Somebody said it. The chart. Can't you go to the chart? Remember those charts that they didn't give you a copy of? You have to look it up on the Z-score chart, right? Now, remember visualize it in your head. What's in the left-hand column of the Z-score chart? The Z-scores, right? What's in the middle of the chart? The percents, okay? So I would go to the middle of the chart, find 0.99, which I did, and I found it to be, the Z-score for that is 2.33. Okay, so make a note to yourself there. Go to the table, look up the area of 0.99, and find the Z-score for that. Okay, put a note on there for you so when you start using this to review with, right, you know where we got the numbers from. So now I know the Z-score, I know my x, I know my mu, and now all I have to do is solve for standard deviation. What's the two ways to solve this?
Algebra.
Algebra or what?
Plug in.
Plug and chug, right? So find the answer. Back over here. All right, now you're going to work on free response, everybody's favorite, right? Before you start, on free response for the AP exam, there's 6 questions on the free response. The 6th question is worth more points, and you should spend more time on it, like no more than 30 minutes. And I always tell my students to start on that one first if you know how to do it. Don't go to number 6 and spend 30 minutes staring at the paper because you don't know how to do it. Okay? And if it freaks you out, just don't start there. Okay? Go find one you know how to do. 1 through 5, you should spend 20 minutes on each. Okay? So if you think you've done that one problem, 1 through 5, one of them in like 5 minutes, you didn't do enough work. Okay? You've got to show everything. You've got to show all the work. You've got to name all the variables. You have to show as much as possible. I've graded exams for the last 2 years, and that's the one thing I've seen on the test is kids don't give enough information. Or they just do the calculator work and put the number, and then you don't get any points, even though you knew how to do it. Okay? So be sure and show as much work as possible. So let's start on 11. We're only going to do A, C, and D on 11. So just do that one for now. And then we'll go on to the other one in a minute. Let me think. Let me give you 20 minutes to do that. They have to have special rules for the tennis balls in tournaments. Okay, so they tell us, first of all, that they're dropping it from 100. The height has to be between 48 to 53. And they tell you it's normal. They're telling you here the mean's going to be 50, and the standard deviation is 1.1 inches. Okay? The first thing I do then is draw a curve. So 50, 51.1, 52.2, 53.3, right? 58.9, right? I mean 48, yes, sorry. 48.9, then 47.8, and 46.7, right? Well, you can see that. All right. So, and you want them between 48 and 53. So I always shade that. So that's going to be about here to about here, right? Okay? So they want to know the proportion of balls, tennis balls, the proportion of tennis balls. So if they say proportion, what do you think? Probability, what else do you think? Wait a minute. What do you think when you hear the word proportion? Probability, what else? What else does probability mean? Area, what else does it mean? Percent, right? So that's what we're looking for. We're looking for the area under this curve. Can I estimate it using empirical rule? Yes. Because this from here to here is 68, right? This much is how much? 13, so that's 81, and then a little bit. So you're thinking it's going to be about between 80 and 90, right? Hopefully. Okay? So let's find the probability statement first. That's going to be, they're asking for the probability that the ball is between, the bounce is between 48 and 53. So that's what you're looking for right there. Now to find that, you have to do what? What do you have to do? Come on. Well, yeah, you're going to go in the calculator and get the normal CDF, but what do you got to do? You got to do the z-score. How many z-scores you got to find? 2. So the first one's going to be 48 minus the mean, which was 50, divided by 1.1, which is the standard deviation. And the next one's 53 minus 50 over 1.1. Okay? Now, what's the z-score for the 48? Sorry, say? Negative 1.8. And the z-score for the other one? 2 point what? Okay? Now let me show you something. And I've been trying to get my students to do this, but they don't. Look where I drew that line. What standard deviations is that between? This is the first one, this is the second one. So it's between 1 and 2, and it's on the left side, so it should be what? Negative, right? So did I get something between 1 and 2 that was negative? Yes, then I did this right. Okay? Where's this one at? Between what and what? 2 and 3, and it's on the right-hand side, so it should be positive. So did I get something between 2 and 3 and it's positive? Yes. So chances are I'm okay so far. Okay? All right. Now what do? Now you can go in the calculator. Normal CDF, 48, 53, 50, and 1.1. What do y'all get? Point what? What did I say it should be about? Between 80 and 90, but I'm somewhere there, right? At least I didn't get like 20%. Then I would know I was wrong. Okay? Right, close enough. Okay? All right, what else do I need to do here? No, because you're doing in between. And it's oh, yes. Oh, good point, Kelly. All right, I didn't read the question correctly. What did I miss? Not meet. So what I shaded was what? What will meet. So what do I have to do to get the right answer? 1 minus that. So 1 minus 0.962 is 0.038, right? This is why it helps to go back and read the question again after you do the work. Okay? All right, what's another thing I have to do? Write the sentence. Okay, I need to explain what this number means. Remember, in stats, it's not about the number you get, it's about what it means. So what does this mean? You start right here where it says proportion. The proportion of balls, that's all you got to write. The proportion of balls produced. Just copy that sentence.